we go. This is a cube root function right here. And without transformation, you can see it over there to the right on my whiteboard. The cube root has got n behaviors that go both directions. And mine is just a little distorted because it has, it's a sketch. So if I wanted to see the real deal, I can go to Desmos, put in my cube root. I got that function on my keypad. That's the square root. Let me see what it, there's the to the power. I wonder what else I could do. Let's see if it's got, doesn't have that. Oh, there it is right there. Cube root of x. Okay, that's the better rendition. See, my little curve isn't as curvy as it should be. Okay, so that's without transformation. Now, if you add 3, go 3 up, that means that turning point right there, that's HK. So here you can't use it on the test, but you can use it to see the transformation and then educate yourself on what it's going to look like on the graph choices. See, on B it went up 4. C it went up 4 and got vertically stretched. And D it went off of the 0. So it should be 0, 3 because nothing is being transformed on the X. H is 0, K is 3. So it ends up being this option. And domain and range have no restrictions. So on this Cartesian plane, all real numbers exist, not just rational. Rational numbers are numbers that can be written as ratios. But the square root of 2 can be found on those real number lines. So real, real, done with number 1. No restrictions. Okay? So cube root of any number can be found on this curve. It's amazing. Okay, this guy goes down 2. So we're looking for a function from the original parent function of the cube root of x and go down 2. So that no stretches, just down 2 on the y-axis. K is 2. I keep going to that tab and I want to go here. So A shows down 2, but it's over. So it's just down, no over. B, that looks like this, the turning point's on a -1. C, turning point's on a -1. And D, yeah, C got either horizontally stretched or vertically compressed. So C is not the right, curve dynamic. So D is the one, down 2. That's cube root, guys. You find it? If I give you the function, could you find the graph? And domain and range are all real numbers. Real, not just rational. Rational is a small subset of, is a subset of real. They're both infinite. But real includes radicals, pi, all those numbers that come out interesting on the calculator. Okay. Now we're just talking. What happened? Remember that our function, so I could type on here. Maybe I could do a sticky, huh? Remember the, maybe I can get a bigger font. Yeah, there we go. Okay. The cube root of, yeah, there you go. I don't know if I have, I'm going to just write the ordered pair. H, it doesn't like lowercase h's. No, I do not want that. Do I X that out? Is that how I get rid of it? Comma. No, I still don't do it. Okay, I'm wasting a lot of time. Okay. And maybe now I just go back and change it and then go walk away from crazy. Go back. Yes. Okay. For this transformation, h is 0. That's what's being subtracted from x. And 4 is the k. That's normal. So it's translated up 4 units. No stretches. Remember which h moves left and right, k moves up or down. This guy, the inside number is 7. Remember, it's opposite of what you see. The outside number is 0. So it's translated 7 units. Crazy, right. Units are never negative. Can't see that very well, can you, on with the screen? Maybe I can pull that screen down since I don't think I write on. But I covered my functions, rats. I've got a tear in my paper. Better than having the screen there. Okay. Comments, discussion. Are you guys keeping up? Get this homework done. Then you can go back and reflect on it. You can always look at your homework. You choose not to write it down on a piece of paper. You've done this before. What are you going to write down on the piece of paper? That little story right there. Those general ideas so you can apply it to any function about the transformation. Now this is a multiplier. It's outside, so that means the value of a, the multiplier a, is doesn't get flipped. And I'll play this game. You do not flip a. You get a hint right here. It's staying compressed. 1/8 is 1/8 because it's outside the, let me see if I go here. Okay, because it's to the left of the cube root function. It's not in the mix. And so you still enter the fraction as is. Compressed means you're multiplying by a number less than 1. Okay, I'll move this down a little maybe. So you could, well, maybe. Don't move that part. There we go. You can see where I'm getting putting my data. Okay, the h is there's none of these transformations, is there? H and k are the original 0, 0 there. Remember, a is a vertical, just like August, September, October, November, December, January, February, now March. Still the same story. Okay, HK is still there, but it's not A anymore. That's being multiplied. It is 1 over B. If 1 over B is 2, B is 1/2. So you take the reciprocal. Oh, pickles. Oh, pickles. You guys know this. You guys know this heartache. 1/2. And it is horizontally because the multiplier is inside. Oops, I covered up my B story. Guys, take the reciprocal of the multiplier inside. You know those vocabularies? Switch it up. Since 1 over B, you see 2, that means the value is 1/2. Just another practice on transformations of any functions in the universe. Okay, my multiplier's outside again. I do have a k, so I go back to A. A doesn't switch, so A equals 5. And k is 2. So translated is the 2, up, and stretched is the 5 vertically. The factor means multiplier. Fun? Having fun yet? Yay. Okay, this is another story. We have an h of a -4. They're all just beautiful stories, and k is normal at a -2. There is no multiplier, so that's the only thing that's going on. Units are never negative, so horizontal, the negative comes up when I say left. And then the units stay positive, but the negative shows up when I say down. Please tell me to slow down if I'm going too fast, okay? Don't be afraid to say, whoa, 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 I don't get it. Otherwise, I'm assuming you're just like me, we're practicing. The only thing you know new is this is the shape of the graph. That's the only new thing. You've learned A, B, H, K for since August. Okay, H is a -5. There's nothing being added outside. So you see right out here is where K would live if there was one, but K is 0. K does exist. And A is outside, so A stays 4. So that means I'm a vertical stretch by a factor of 4. So that's what that means. See if I get it. Oh, pickles. Disappear. Disappear. Reappear. Come back. Get my right script in order. There we go. I wanted to pull that down just a little bit more. There we go. Okay. So -5, 0. A is out. I need to be right here on my graph. Didn't go up or down. B is in the right space, but I got to count to see if it stretches 4. That means it goes up 2 over 1. Yeah, that one does. Remember how to find the stretch? You go from the starting point for a square root function, the vertex from a parabola or an absolute value function, the turning point for a cubic or a cube root function, in any of those, right? So C is at a -5, but it isn't stretched. C is normal. Go up 1 over 1, and then you run into the graph again. D is not on the right turning point. And I don't think we have to talk about the right, domain and range anymore. Just remember, cube roots have no boundaries, no restrictions. Those are difficult to read. Hopefully you can zoom in and get the right dynamic. Okay. 10 has a no, H is 0, K is 2, so there isn't, and the stretch is 5. So I'm going to have even a taller looking curve. That's my personification of the curve. It looks taller, but the way you do the math, if you put a cube root of a number, take it times 5, it's going to grow by a multiple of 5. Then when you add 2 to it, it goes up 2 on our y-axis. So I'm going to check to see if I count 1, 2, 3, 4. Oh, it goes by 2, sorry. 2, 4, 5 over 1, yes. B is my answer. There's no reflections on this one. We haven't had a reflection yet. Interesting. They haven't challenged us with that. Hopefully we have some of those on our practice test. Okay, C is not on the right correct turning point. It should be 0, 2. Should be 0, 2. Not 0, 2. So B is winner, winner, chicken dinner. Okay, this one looks challenging, but it's not. It just tells you where in the world would you find this information. Well, the length of the side of a cube is modeled by this formula. Oh, look, there's a cube root formula. Select the correct graph of the function. Use the graph to find S, which just use your technology, please and thank you. When V equals 45, round your answer to the nearest tenth. So first you have to find the right graph, and then they want you to find S. So the key here is if I look over for V is 45, and whatever my calculator calculated, I will know it's the right graph. So there's my 4 choices. Let me zoom in so you can see them all together. Whatever I find in my calculator, I have to round it to the nearest tenth. Obviously, you can't do that from the graph. It's so, it's counted by tens. How in the world could you round it to 1 decimal place? So let me go to sphere, look at our calculator. And this is how you put in a cube root if you've forgotten. Okay. I want a cube root, so I hit the 3, just a 3. Then I ask the function to go second and then the caret. And that's what you should see. Now my number was 45. You guys need to enter your number in. But the cool thing about this, all the graphs are alike because we have all the same formula. I just have to look over to 45 and look up and see what the output value is. 3.6 would be mine. So I'm going to go ahead and put 3.6. And I'm going to look at 45. Oh, I guess that one right. C was it. At 45, see, it's not even close to the blue line. At 45, not close to the blue line, 3, a little over 3, or a little over 3.5. At 45, there's where 3.6 is. So I know I have the right graph. Everybody's graph should look like this because we all have the same formula. So whether you had 27 for your number or 70 for your number, you'll have the same graph, just a different value depending on what your volume was given. So there's a context problem for cube root. Why would you want to have that? Where would you see that? And that's if you have the volume and you want to find the length of the side of a cube for your industry, whatever you're creating, or digging, or fixing, or whatever you're going to get to do with your beautiful life. Individual help? Anybody need individual help to get their right data? All right, this is another just plug and chug. Know how to enter it in your calculator. If you take the decimal and then you put the multiply sign and then cube root of your m. My m is 177. My decimal is 0.32. We're all different. So 0.32 and then put the multiply sign. If you don't, or maybe parentheses around, whatever you want, but you're not going to get the right function when you put the cube root in. It won't, it won't separate the two ideas in the calculator. And then mine was 177 for its mass. There is mine round to the nearest hundredth. I had to put in 1.80. That's my 6 makes my 9 a 10, which makes my 7 an 8. But it asks us to round to the nearest hundredth. Therefore, I got to tell it I rounded to the hundredth place. Okay, so this is what your screen should look like with your numbers on your calculator. Okay, 2 more. You're graphing the parent function, and this is the key on your tool on your iPad that you put in the cube root. That's our story, cube root functions. Everybody see that? That's the parent function. Then what happened? 6 left, 10 down. Oh boy. I got the coffees too. Get rid of this for now. That was fun. Hopefully you can remember you enter units. When you enter units, there's no signs to them. Left has a negative connotation and down means negative. Okay, 14. We have to upset the apple cart and solve for R. How are you with that? Okay, I'm going to have to probably, I don't know. Can I write with a pencil on stickies? Probably not, huh? Nope, I have just type, right? Okay, let me see. Somebody else have a software that works to write on? No? Let's see if we can find one. Probably not. I'm sure there's, you know what? I think there's probably one. It's probably a add-on, an extension. So, okay, maybe I'll do the best I can up here. Okay, I start out with the volume is a fraction, and the pi is next to the fraction, but it's really with the 4. So there we go. Okay. And then it's times r cubed. Okay, that's how you write it if you don't have a upper, a superscript. Okay, so I'm going to move that 4 pi over 3 by multiplying by a reciprocal. So it ends up with the 3 times the v over the 4 pi. And that is r cubed. So the inverse operation, get rid of the cube, I have to take the cube root. So this is how cube root of 3v over, 4 pi. Option B. Okay, I'm going to stretch this out just a little bit more, is my r. So that looks much nicer in my software. Here's the cube root button. And then inside, in the numerator, I have the 3 and the v. And the denominator is the 4 and the pi. And there is a pi button. And that's another place where you will find a cube root function in science. If I give you the volume, can you find the radius of the sphere? So they manipulate the formula so it's your answer is your radius. Here we go. So you just, reciprocal and call it a day. Everybody have a chance to get that? Write it down or type it out. Great context question.